But I did get some email questions from people too, and I didn't know if any of those were the same ones that you had or not. So so we'll see. But what did you have to go over?
I had questions on the which assignment? The optimization.
Mm-hmm.
And I couldn't do the second one, and the last one was kind of confusing.
Okay. Was the last one number 10?
It is number 10, yes.
Okay, because somebody else had asked me about number 10.
Okay, yeah, we can do that.
Weird thing is I had notes on number 10 from when someone else asked me. I don't know where they are, but I guess it's not that weird because my whole life is just covered in random calc notes that go missing. But that's okay. We'll do it again. So you said the second one?
Yep.
Hi, Isabella.
Hi.
Finn was asking about optimization number 10, and then the second one, whichever that is. So I'm going to find it in a second. Someone else had asked about 8 and 10. And then I don't know what you had prepared, if anything.
Yeah, I was confused with the questions Burfin asked about as well.
Okay. All right, let's look. Okay. So number 2 then.
For this one, I did like 2 plus y and like -7, I think, because it says like there's a 7-meter opening, but I'm not sure if I was supposed to put like -7 there or like somewhere else. So like I got it wrong, but like yeah.
Okay. So we have 3,300 meters of fencing at our disposal. The plot is rectangular. It borders a straight highway. Okay, so here's the highway. I don't know exactly what the rectangle looks like. If she decides to fence along the highway, except for 7 meters to allow for access, so let's take off that 7 meters. What is the largest area that can be enclosed? Okay. All right, so kind of depends on how you want to label this. I'm just going to go like this because to me, Y should be vertical and X should be horizontal. All right. So since this side is X, I would take this side and just call it X minus 7. Is that the way that is that what you were thinking when you said it?
Yeah. Like this is how I did it, but I just got it wrong somehow. So.
Okay. All right, let's see. Sorry, I keep losing you on my screen. There you are. There are too many things going on. Okay, so we know that we're going to fence all around the rectangle. We know that if we take 2y plus x minus 7, that's going to give us the 3,300 meters. But regardless of whether or not we fence on this little 7-meter piece, we're still going to have the same amount of area inside the rectangle. So the area is still going to be x times y. Okay. And then we'll just simplify this. Technically, I don't have to have the meters on here. That's probably throwing things off too. So I have 2y plus 2x, and then if you want, you can go ahead and just add the 7 on both sides. And that's 3307.
I didn't add, but I did -7. Like,
Oh, you
so I
subtract.
put it as like minus, so like, 3,300 minus 7, not plus 7. So I guess that's why I got it wrong.
Oh, well,
Yeah.
that'll do it. What about you, Isabella? How are you doing so far on this one?
Well, the first time I tried it out, I forgot to include the 7. I thought it was like the same thing as like the last problem, sort of, and then I read it again, and then I subtracted 7.
Okay. All right. Well, this is the setup. Are there any questions on the setup? Because once we're here, it's pretty much what we did in class, I think, with the rectangular plot of farmland. Oh, in class, I guess technically we had 3 sides. So this is like 3 sides plus like another segment. Okay. Wonderful. Then let's just finish this one out. Then we can move on. I feel like my focus could be better. Okay. Terrific. All right, so pick one of the variables to solve for. No matter which one you choose, you're going to have pretty much the same situation. So I'm just going to solve for y. 3307 minus 2x. And then y equals 3307 over 2. And then when you divide both terms by 2, you're going to take 2x and divide it by 2 and just get x. Now we have this area, which we wrote up here as x times y. So now we'll write x times, and then we'll sub out for y. You guys, I'm so happy to have the office hour today. I can't even explain to you that my kids, I don't know what has gotten into them today. They're like down there screaming, and I'm just like, oh my gosh, I need to escape to do some calculus. It's like a brain shift right now. I'm so happy. All right, let's see. 3307 halves x, and then minus x squared. So just distribute there into the parentheses. And then once you have a written all in terms of x, we can go ahead and take the derivative. So we have dA dx is 3307 halves minus 2x, and we'll set that equal to 0. And it's kind of up to you how you want to solve this. I would just say add the 2x on both sides and divide by 2, and you'll get x equals 3307 divided by 4. Your question was asking what's the largest area that can be enclosed. Well, here's your area expression, the equation. So if you want to get a decimal, fine, but I wouldn't truncate if I were you. So I would say the area is 3307 fourths times 3307 halves minus 3307 fourths, and then just simplify that. 3307 fourths times 7 halves minus getting approximately 683,515.5625. That might even be exact. You know what's interesting to me? Oh, it does say it around to 4 decimal places. Okay, well, that's what my calculator gave me. So I don't know if there are more decimal places. It's possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's possible that there are. Don't know. That's what my calculator gave me. Meters squared, because it's area. I know WebAssign always gives you the unit. That's one thing I missed about my math lab. You had to actually pick the unit out of the dropdown. All right, so that was number 2. We'll do number 10 and then come back to number 8. Did you guys do 8 okay?
Yes.
Okay, what about you, Burfin?
I tried doing 8, but I was stuck, so I didn't get to finish it.
Okay, well, I'll do 10 first then, and then I'll do 8 after.
Okay.
So I had an email question for number 8, and actually I had another WebAssign question on number 8 also, so I do want to make sure we get to it. But if Isabella needed help with 10, that one first. Let's see. And with this one, it looks like the only thing that's changing is the perimeter of the window. A Norman window has the shape of a rectangle surmounted by a semicircle of diameter equal to the width of the rectangle. As shown in the figure. If the perimeter of the window is 14 meters, what dimensions will admit the most light? All right, so what you're thinking here is, good, you can see that, excellent. For the rectangle, it's kind of up to you how you want to label this. I guess you can go with Y. The thing is, because you're dealing with a circle here, I was thinking that we should use R here for the radius. I had such really nice notes on this the other day, but I don't know where they went. Maybe I recycled them. I don't know. Oh well, make new nice notes. I don't know if I emailed them to somebody. Don't know. Okay, and then you can call the height whatever you want. If you want to call it H, that's fine. If you want to call it Y, that's fine too. I'm gonna call it Y. If you want, you could do the standard rectangle thing, and you could call this X, and then you could just rewrite R in terms of X, if you'd like. It's kind of up to you. So we can say that this is R, which is the radius, because I think that's helpful to see. But then you can note that R is going to be 1/2 of X, because the diameter of the circle is the same as the width of the window. That's what it said. The diameter equal to the width of the rectangle. Okay, so the perimeter is 14 meters. So basically, though, this is your picture. And if you like to keep everything in terms of X and Y, I kind of do. We can do that. Kind of up to you. But this is the picture that you're dealing with. And the reason we need to talk about the radius is because we're going to have to talk about this circle in terms of geometry. It says here, what dimensions will admit the most light? Which means that we're trying to maximize the area. If we're trying to admit the most light, we want to make the window have the largest surface area as possible. And because it's a 2-dimensional shape, we'll just think about that as being area. So we're going to need to come up with 2 equations. One of them is for area and the other one is for perimeter. If you want to do perimeter, I don't know. Let's do area first. So the area of your window is the area of the rectangle which is x times y. And then you're going to add on half of the area of a circle. Now remember that the area of a circle is pi r squared. We're going to write this again, by the way. But you're taking half of that. And I want to make sure this is clear. Because you just have a semicircle. So that's why we're taking half of that. I also want to make sure my notes are clear because I know there were a few people who said they couldn't come to the office hour but wanted to. So I want to make sure everything's labeled nicely. Okay, but now we've already discussed the fact that r is going to be 1/2 of x, and we don't want to have 3 variables. If anything, we want 2 variables, and then we can substitute in and create 1 variable, but having 3 variables is kind of a mess. So we're going to rewrite this again. The area will be xy plus 1/2 times pi, and then r will be x over 2, or I mean, write it however you want. If you prefer 1/2 x, that's fine, squared. So just subbing in for r. And we'll simplify this again. So we'll have 1/2 times pi times, and then when we square 1/2 x, we'll get 1/4 x squared. And then we can move that parenthesis and just multiply, get this into a better form. So we have area equals xy plus 1/8 x squared pi, or pi x squared. Maybe we'll do that. Okay, are there questions here? Are you sure? No questions? Good.
To get 1/8, you just multiply them?
Yep, the 1/2 times the 1/4. Yep.
Okay.
Yep. And you know, this is the office hour. It's just the 2 of you. So if you have questions, now is really your time to ask. This is your time. All right, so there's your area equation. I'm just going to put a box around it because I want to make sure I can easily refer back to it when I need it. And now we'll make an equation for the perimeter. For the perimeter, we're looking for the distance around. So I think, you know, the rectangular perimeter is no big deal. Oh, and by the way, in your picture online, it has a dashed line here. So I just want to make sure we understand that it's not like there's some sort of situation where you have like extra, I don't know, like borders around the window. This is all just open space here. So for your perimeter, we're looking at y plus x. So I'll say 14 is equal to 2y plus x plus, and then we're going to look at the circumference of a circle. So the circumference of a circle is 2 pi r, if you don't remember, and we only have half of a circle. So this is the circumference of a circle, and then we only have half of a circle. So we're going to rewrite everything in terms of x and y, and then we'll simplify this out, and then we'll substitute and take a derivative. Irfan, you look so tired today.
I was up till 3 a.m. and I was finishing up the graphs.
Oh.
These.
Did you find that you were super productive at 3 a.m.?
I feel like I'm not productive in the morning, so
Yeah.
afternoon I start working usually.
Me too. I'm much better at night. I was up till like 3 a.m. too. I was working on your test. I'm always like racking my brain going through like, do I want to do this? Do I want to do that? And testing stuff out. No matter how much time I put into it, something will still end up being like, man, I didn't expect they were going to do that. I wish I would have done something different. It takes forever to write you guys' tests. Probably longer than it takes to grade them. All right, so I'm just going to simplify this by multiplying the 1/2 times the 2, and then I'm going to substitute r equals 1/2 x. But yeah, definitely if I don't get a nap, I feel like by 2 a.m. my brain's sluggish, and then it's just like pointless. Like I feel like I'm not getting anywhere. Do you feel that that happens to you?
Yeah, I was trying to find the derivative for the last 2 questions, and I just couldn't, and I was just like losing my mind, like how can I now find the derivative? Like it's the easiest part, you know? But I figured it out this morning though, so it was
Yeah.
good.
Sometimes you just gotta, look at it with a fresh pair of eyes.
Yeah.
All right, so this isn't going to get too much more simplified actually, but maybe you want to write it like that just to make it look a little bit better. Okay, now we're going to have to sub in a variable for the area equation. Since we only have y once here and once there, my suggestion would just be to solve this equation for y and then sub it into the area equation and have everything written in terms of x. So you'll have 2y equals x. Or, let's see, I moved it to the other side. Change the side, change the sign. That means I'm going to have 14 minus x minus 1/2 pi x. So I just subtracted x and 1/2 pi x from both sides. And then you end up getting y equals, divide every term by 2, 7 minus 1/2 x minus 1/4 pi x. Now, once you have that, we'll put this back into your area equation and simplify that, and then eventually we'll take a derivative. 7 minus 1/2 x minus 1/4 pi x plus 1/8 pi x squared. Seven x minus 1/2 x squared minus 1/4 pi x squared plus 1/8 pi x squared. And if you'd like, you can go ahead and combine these two terms now. You don't have to, but they're both pi x squareds. So you can. Negative 1/4 plus 1/8 will be negative 1/8. And now it's ready to take the derivative. I'm going to put a box around this too so that we can come back to it later in case we need to. Anything that's super important, I'm just going to box. It's probably fine. Okay. Questions here? Wonderful. Let's take the derivative of the area with respect to x. I kind of want to go back and just make sure I'm answering the right question. Oh, it's just asking for the dimensions. Okay. So let's go ahead and take this derivative. 7 minus, multiply by 2, and you just get x, and then minus 1/4 pi x. set that equal to 0. And if I were you, I would probably leave the 7 and then move these two terms to the other side. Factor. And then you get x equals 7 divided by 1 plus 1/4 pi. Moment of truth. 1 plus pi over 4. And you get that x is approximately, let me look at your rounding instructions here. You know, there are no rounding instructions on this problem. Do you find that that happens a lot? And when it does it just accept any number of decimal places?
It didn't accept. It accepted like 3 or 4, so I had to keep guessing until I put the right amount.
Really?
Yeah.
That's weird because it doesn't say. All right, well, we're talking about meters, I think. Meters, yes. Okay. All right, so this is what I got for x. So this will be the width of the window. And it's asking you for the width and the height. Well, we have y. So y will be the, interesting. You know, the way that this is being asked, when they ask you for the height of the window, do they want the height of the rectangle plus the height of the semicircle?
That's what I was thinking too. I was confused with this one.
Interesting. Yeah. Well, let's see what happens. Because y is technically not going to be the height of the whole window. It's just going to be the height of the rectangle. So we might need to add that to 1/2 x. So let's see what happens here. 7 minus 1/2, and then I'm going to hold on to this decimal that I have in my answer in my calculator. I'm going to pull that back up again. And then if we need to, we're going to add 1/2 x to it. So this will be the height of the rectangle. And then the height of the semicircle is going to be 1/2 x, because it's just the radius. So we might need to add that in. So let's see. I'm doing 7 minus 1/2 times my answer minus 1/4 times pi times my answer. 7 minus 1 times the answer minus 1/4 times pi. And this will give me the height of the rectangle, which is 1.96, which appears to be the answer they're looking for. So I'm going to leave it there. So the height of the, I don't know, I find that to be really confusing. So your answer here for the height of the window that they're looking for on WebAssign would be 1.960 meters. Yeah, that's kind of confusing. And I'm thinking too, if you, like, let's say that you got the width correct, and then you entered the height wrong, would it tell you that you got one of them right and the other one wrong? Like, you would know, right?
Yes.
Okay, so then you could at least say, okay, maybe I didn't enter what they were looking for, and then you would go back to this. Okay, just wanted to make sure that you wouldn't question your whole solution process, because at least if you knew this was right, then you knew you were pretty much not even on the right track, but you were good to go. Okay, wonderful. So we took, I want to make sure these, I know these notes look nuts now. Okay. All over the place. I am going to do number 10. I don't know if anyone has to go right away, if there was one you wanted me to do earlier, or if you want me to just go ahead and do 10 now, because I think, Isabella, you said you already got number 10. So do you have to jet, or do you have some time? Is there something you'd prefer I do first?
No, I was just gonna stay here like the whole time and see what you went over.
Okay, but you didn't have like an agenda of things that you wanted to see.
No.
Okay. Because I do need to go over number 10, because I had a couple people submit questions about it. Let's see.
You mean number 8?
Oh, sorry.
What?
Number 8, yes.
Yeah. Okay.
Yes. I did them backwards, so sorry, yes.
That's okay.
I just did number 10. So yes, number 8. Okay. Put that to the side. And we will do number 8. 4, 7. A cylindrical container. Let's draw that. That has a capacity of, I'll do this variation, 10 meters cubed. Capacity and the meters cube would indicate volume. Is to be produced. The top and the bottom are to be made of material that costs $20 per square meter. And the sides are to be made of material costing $10 per square meter. Find the dimensions that will minimize the cost of the material. All right, so we need to set up 2 equations. One of them will be a volume equation, and the other one will be a cost equation. Now, the cost equation is going to discuss surface area. So if we're minimizing the cost, we're minimizing the surface area. Well, I don't want to say that. We're minimizing the cost, but the cost has to do with the surface area of the materials that we use. So we'll say that. First, we can write an equation for the volume. I gave you an equation the other day for the volume of a cylinder. And when we did a cylinder problem in class that was very similar to this, we had hemispheres on the ends of the cylinder. This time we just have a cylinder. I know the way I drew it, it looks kind of like we have hemispheres on there, but we don't. We just have the cylinder of radius r, and the height of the cylinder is h. And normally I do like to use x and y, but if I have something that's geometrical like this that has formulas that rely on r and h, I tend to just go with those. So the volume of a cylinder is pi r squared h. And that's equal to 10 in this case. So pi r squared is the area of the circle. The h represents pulling that circle out. Now, as far as the cost is concerned, we'll talk about actually looking at how much the cost of each piece will be. So for the cost, all right, C equals, first let's talk about the top and the bottom. So the nice thing is it's just a cylinder. We don't have that situation where we have the hemispheres on top. The area of the circles on the top and the bottom will just be pi r squared for each one. So twice pi r squared. So remember that pi r squared is the area of a circle. And we have two circles. Now that will be in meters squared, and then we're going to multiply this by the cost for the top and bottom, which is $20 per meter squared. So you'll just be left with dollars because your meters squared will cancel, and we don't need to worry about writing down the units in this case because we've already labeled it cost. And then we'll add that to the surface area of the sides. And I think this is one that people have a harder time coming up with. So for your cylinder, remember that you're going to create a cylinder by taking this. A rectangle and just making a circle out of it. So there's your rectangle. We made it into a cylinder, or the sides for a cylinder, just by kind of swinging it around itself. But no matter what, the circumference of this will be just whatever the height of your paper is. So if I have this paper and it's h pi, and then I fold it around, well, I have the circumference times h, and that's going to get me the surface area of the sides because it's really just that rectangle. So we'll go with that. So we have the 2 pi r squared, and then we have 2 pi r, which is the circumference, and then times h. And we just have one of those. So 2 pi r h, and then we're going to multiply that by 10. Oh, I should mark these. Cost per meter squared. This would be cost per meter squared. And then this is the surface area of the sides. Or I could say area of sides. Technically, it's like a side, but we'll call it sides. So yeah, so the circumference is just your one length of your paper, and then the height is the other. Okay. There was one more thing I was going to label on this, and now I can't remember what it was. Oh, maybe I was just going to like specifically label that this was the top and bottom. And this was sides. I keep wanting to call it side, but it's so weird. Okay, so the setup is crucial. Are there any questions here? Okay. And by the way, I don't know if you guys noticed, but on B2L, if you have notifications set up when you log into B2L, there should be a little notification saying anytime I add a file. But I added the geometry handout in the content section to the handouts. Oh, yikes. Oh, there's our class. Something happened to my D2L, but everything's okay. It's under handouts, and it says geometry and algebra formulas, and you will be allowed to use this on your test. And it does have a right circular cylinder, and it has the volume and the surface area So you can see the volume is pi r squared h and the surface area is 2 pi r h. So that is all on there. In case you did not notice, you may use that on your test and the formulas are right there. So, I mean, you didn't have to derive them. If you guys have questions, feel free to pop in and ask. Wonderful. So let's simplify this cost formula. So 2 times 20 is 40. So we have 40 pi r squared. And then 2 times 10 will get us to 20 pi r h. And now we're going to rewrite this equation to be written in terms of one variable. I only have one h, so that's going to be the easiest one to sub out. And that's going to be nice for us here too, because I just have h to the first power, so it's going to be easy to solve for h. So I can write that h is equal to 10 divided by pi r squared. All right, so I'm going to sub that in now to my cost equation. 40 pi r squared plus 20 pi r times 10 divided by pi r squared. You know, it's just this process of simplifying and rewriting. So I'm going to get 200. The pi's are going to cancel, and you're just going to have 1 power of r left in the denominator. Since it's in the denominator, you might want to just go ahead and note that and just write it as r to the negative first, and then you'll have 1 fewer time that you'll have to rewrite this before you take the derivative. Now everything's written in terms of r. Remember that pi is just a constant, so it's not a variable. We don't need to worry about that. We're just going to treat it like we would any other constant. Let's go ahead and take dc dr, or you can call it c prime if you don't like dc dr. All right, so 40 times 2 is 80, and then pi r, so that pi just gets dragged along. And then minus 200r to the negative second power. And then we'll set that equal to 0. Actually, if you want, you can rewrite this as a fraction. I know we have been doing that, so I'm trying to be consistent. So if you write it like that, you'll write it as minus 200 over r squared. And then if you want to write this as one fraction, you can do that too. You don't have to do it, especially in this case, because r isn't going to be 0 anyway. So you don't actually have to worry about the denominator, but we have been doing it. So consistency is key. And then you can just multiply the first term by r squared, which gets you 80 pi r cubed. So remember, when we're looking for critical numbers, the reason we don't need to worry about the denominator in this case is because the only way the denominator can be 0, which means dc dr would not exist, would be if r is 0. And then, of course, if r is 0, the radius is 0. And if the radius is 0, we don't have a cylinder. So we don't actually have to worry about that instance in this case. But we can go ahead and take the numerator and set it equal to 0. And solve for r. You know what? I'm just going to divide by 80 pi. And then in your calculator, by the way, if you hit the math button, number 4 is a cube root. So that will make your life a little bit easier when you're solving for this. But you'll take the cube root, and yours might not have a template like mine does, but you can just use parentheses. Remember, when you divide by 80 pi, you must put parentheses around it. Otherwise, your calculator is going to take 200, then it's going to divide it by 80, and then it's going to multiply that quantity by pi. So I'm going to show you what that would look like. This is not the same thing as that. Students mess this up all the time. It's very common. It's a very common error. Your calculator doesn't know that you want 80 pi as a product. So it's going to take 200, it's going to divide it by 80, and then it's going to multiply that quantity by pi. Not what you want. So you might be like, oh, this is fine, and you did all your work and you got to the end, and then you're just like, wait a second, why is my answer wrong? Be careful. Put parentheses around it. That gets you to the right answer, because now you're dividing by that entire quantity, 80 pi. So it's possible that people are doing this. I should actually check and see if the person who submitted it got that answer. No, so that's not what they did, but just never know. Okay, so we have R is approximately equal to 0.9267-ish. How many decimal places are we using here? 3. Okay, so 0.927. Meters. And you are being asked, what is the radius? What is the height? Okay, so we have R, and then we know that H is 10 divided by pi r squared. And again, I'm going to be really careful with how I input this into my calculator. I'm just going to use the answer that I had previously. So I'm going to take 10, and I'm going to divide it by, in parentheses, pi times the answer squared. You're going to get 3.707. Meters. Height. Okay, it's good stuff. We still have 11 minutes. So what else do we want to talk about? Or do you have questions on this one?
It shows us wrong when I put it in.
Well,
Yeah.
did you have the same numbers though for yours? 10, 20, and 10?
I got 10. Oh, I had 15. Okay. I had 10, 15, 20.
Yeah,
So
so you're gonna have to go through and change all those numbers.
Yes.
No, I used your numbers on the first two. Sorry, someone submitted this to me. That's why I used their numbers.
That's okay.
Yeah. So, and the worst part about that is it's really hard to spot change. So if you go through your work again and just replace them, every time something's going to go wrong, and you might as well just start over at this point. Sorry, Burfin.
That's fine.
Okay. Yeah. Oh, gosh. All right. What else do we want to talk about, if anything? You have me for 10 more minutes before my husband leaves. I have to go tend to my screaming children again. I bought them yoga mats, so I'm going to see if they'll do some yoga today. They're really excited. Little kid-sized yoga mats. They're always fighting over who gets to use the adult ones. Isabella, did you have anything else that you want to? Oh, you already said you had no agenda. I didn't know if anything might have come up.
Because I have another question.
Sure.
For number 5, it gives us the area. So I know like x times y is 1350, but and then the and it's a wait. It's like a two plot thing. So it's like the question number 4. It's very similar to that. So I was like, oh, like, I'll do it. But it gives you the area and it wants the dimensions from you. And I got confused with this one.
Okay. Let's see. So you did number 4 and you felt comfortable with it.
Yeah.
It was the number, yeah. Okay, so number 5, yeah, it's like you're given different pieces of information. Okay. So this one says, a realtor wishes to enclose 1350 meters squared of land in a rectangular plot and divide it into 2 plots with a fence parallel to one of the sides. Okay. What are the dimensions of the rectangular plot that require the least amount of fencing? Okay, so we want to minimize the perimeter, but no matter what, the area is going to be 1350. Interesting. Okay, so you've got this situation going on. Okay, let's see. We'll still call this X and Y. I think. Rectangular plot, then divide it into 2 plots with a fence parallel to one of the sides for the dimensions of the plot that require the least amount of fencing. Okay. So this is the picture that I would draw. And actually, I believe this matches the picture that you had for number 4. Okay. So let's see. If you are trying to minimize the perimeter, oh, I know why I'm looking at this funny, because my numbers are slightly different. That makes so much more sense. Okay. All right. Your area, X times Y, is still rectangular. You're still looking at 1350 in that case. And then your perimeter, we don't actually have any values for, but we'll just say that P is equal to, in our case, that's 2X plus 3Y. Now, this is the quantity that we want to minimize, least amount of fencing. Okay, so we're going to solve for our variables in this area. Pick one, it doesn't matter. Either one's going to be the same amount of work. I can say that Y equals 1350 over X. And then P will be 2X plus 3Y, which is 2X plus 1350 times 3 is 4050. And I'm going to write this as X to the negative first power, because you know that you're going to be taking a derivative. So far, so good?
Yeah, I did all this.
You did all this?
Yeah.
Then let's see what the problem was. Okay. So you did this. You took the derivative. dp dx is 2 minus 40/50 x to the negative second. So over x squared. If you want, you can write that as 2x squared minus 40/50 divided by x squared, up to you. And then you'll take the numerator, because we don't want x to be 0 anyway in the denominator, set it equal to 0. 2x squared is 40/50, x squared is what, 20/25. And then x is equal to the square root of 20/25, which is 45. Looking at what you did. I'm not sure. Okay, so what happened between here and here? Did you find something that went wrong, or did you just answer a different question?
So I guess I didn't take the derivative when I had to. And that's where I got confused with it. I took the... I can't even tell what I did. Minus 3y. Like, I just know, like, the numbers I see, like, I use them, but I don't know what I did.
Was this at 3 in the morning?
Yeah.
Okay. All right, so we have x is 45, and you know that y is equal to 1350 over x. So 1350 over 45 is 30. Meters. So how are you supposed to answer this? Length times width, which also I find kind of irritating because some students think of length and width differently. Like personally, I guess I would think of width as being x, right? Wouldn't you? And then I would think of length as being y. But it looks like they have length as 45 and width as 30. Am I thinking of length and width wrong? When I think width, I always think horizontal. I don't know. But it looks like the way they want you to enter your answer is 45 as the length. So that's frustrating too. You know, I would get upset about all these WebAssign issues, but they're dropping our course next year. I mean, next semester. So I'm never going to have to look at it ever again. So just kind of like, how much effort do I want to put into hassling these Cengage people? Yeah. Anyway, other questions on that?
No,
I have a quick question.
Go ahead, Isabella.
So what would we do differently if it were asking for like the most amount of fencing?
We're asking for the most. Well, that would be a completely different solution process because you'd probably be in a situation there where you'd be looking at an endpoint, like what we did in 4.2 when you were talking about absolute mins and maxes. This is what occurs at your critical number. I'm guessing you'd have to look at what happens at an endpoint in that case. That's a good question, though. There actually were some like this in your book, but they were much more complicated, so I didn't include them. But yeah, you'd have to consider the actual endpoints for the fencing that you could use and then evaluate your function there. So You're right though that we technically should have been verifying that we had a minimum. I didn't even think to do that because technically I was just going for finding your answers here in this case. But if you were actually looking for maximizing the perimeter, that would probably occur at an endpoint in the interval, and your interval would have to just include values that would be possible for the amount of fencing on the perimeter. So we can talk about that more another time if you wanted to tune in for a different office hour. Feel free to. We'll talk about it some more. It is 2:02, so you don't need to worry about it. I'm not going to ask you to find anything that's at an endpoint. If there's something I want you to find, it's going to follow these solution processes. So sorry for the kind of answer.
No, that's fine. Thank you.
You're welcome. All right. Well, thanks for tuning in. I'm going to scan and upload the notes, and then I'll just kind of note on here which ones we did so that people are aware. And I will see you tomorrow. I'll be on. I might try to come on earlier tomorrow. I'm not sure how much earlier. It kind of depends on how much time I have to spend finishing up your test. Like, I think it's done now, but I haven't actually done my second draft, so we'll see. But at least I'll be on at 5:30 tomorrow. So that is all. You guys have enjoy the rest of your weekend. Nice afternoon, and I'll see you tomorrow.
You too. Thanks so much for your help.
No problem.
Bye. Thank you.
Bye. Bye.